Hi viewers, welcome to Pharmacy by Asim. This is Dr. Mahnoor Khan, and in this video I'm going to explain an action potential. But first, if you haven't subscribed to my channel yet, please subscribe Pharmacy by Asim and keep following us for informative videos. Moving towards my topic, that is action potential. In simple words, action potentials are nerve signals. Neurons generate and conduct these signals along their processes in order to transmit them to the target tissues. An action potential or nerve impulse causes a movement of ions across the cell membrane of a neuron, similar to a ripple passing along the surface of a pond. The cell membrane of the neuron contains thousands of tiny molecules known as channels. These channels allow either sodium or potassium ions to pass through the membrane. Generally, the channels on the neuron are closed and the membrane is said to be in a resting state. In this state, the charge of the inside of the cell membrane is more negative than the outside. The voltage inside this membrane is about negative 70 millivolts, meaning that the inside of the neuron is about 70 millivolts less than the outside. The cell membrane of a neuron is polarized because of this electrical difference across the membrane. Now, a nerve impulse starts. When pressure or other sensory input disturb a neuron's plasma membrane to the point that the potential difference reaches a threshold voltage of about negative 55 millivolts, this causes hundreds of sodium channels in that region of the membrane to open briefly. This in turn allows positively charged sodium ions to flow inside the cell membrane. Now, the inside of the membrane temporarily becomes more positive than the outside, which in turn causes the voltage to rise. This is called depolarized state. The membrane is now depolarized because the net charge inside the axon changed from negative to positive as sodium ions enter in. As the impulse passes, the potassium channels begin to open, allowing positively charged potassium ions to flow out of the membrane, which cause inside of the axon to resume a net negative charge. At this point, the voltage would fall. The membrane is now said to be repolarized because again it is negatively charged on the inside and positively charged on the outside. So this depolarization and repolarization of a neuron membrane is called an action potential. Action potential is just another name for a nerve impulse. After a nerve impulse is some voltage-gated potassium channels remain open, resulting in further movement of potassium out of the cell. As the voltage falls below the reading of the resting state, the membrane is said to be hyperpolarized because it is even more negative than at the beginning. At this stage, neuron is unable to conduct a nerve impulse and it's said to be in the refractory period. The refractory period is a very short period during which the sodium-potassium pump continues to return sodium ions to the outside and potassium ions to the inside of the axon, thus returning the neuron to resting potential. So in summary, an action potential is just a wave of depolarization and repolarization. It's not an electric current. It's just a series of voltage-gated ion channels open and close. So viewers, that's all for today. Thanks for watching. Make sure to like and share, and hopefully I made it really easy to understand. Thank you.